In this lesson, we're going to work in the opposite direction than we've previously been working with polynomials. So, given an area, we're going to find the length and the width. So we're going to look mainly at rectangles, and remember that with a rectangle, area is equal to length times width. So I need to find two things that would multiply together to give me this polynomial right here, the 7x squared plus 35x minus 168. So if I'm finding two things that multiply to give me that, I recognize that I'm going to need to factor. So when I factor, I'm going to begin again with the greatest common factor. So my GCF here is 7. So I'm going to factor out my 7, which will result in x squared plus 5x minus 24. And now I have a trinomial remaining, so I am going to factor this trinomial using whatever method you know. If tic-tac-toe is your method of choice, set up your board, x squared, negative 24, and 5x. My factors of negative 24 tell me I need a positive and a negative. Potentially it could be 1 and 24, 2 and 12, 3 and 8, 4 and 6. Okay, you do enough of these, you start to spot in advance. I think 3 and 8 is going to work for us. 8 here, 3 here, multiply across, gives me 8x. Again, negative 3x does add to 5x. Okay, if you haven't done much factoring practice, it's going to take you a lot more trial and error. Refer to the previous lessons on factoring if you need additional assistance. So this factors into x minus 3 times x plus 8. So what is the length and width? Well, the length and width here are going to be one of the factors and one of the others. Now you got this 7 out front, so what do you do with that? Well, I just put that with one of them because perhaps the length is 7 times x minus 3 and the width is x plus 8. Now technically that 7 could be with the width, but you're just giving one possible combination that would work. So you could also say that this one here is 7x minus 21 and the width is x plus 8 would be a different way of saying it, right? But I'll accept it if you get it to this. The only thing I'm missing here would be units, and back at the start I had inches squared, so this would be 7 times the quantity of x minus 3 inches and x plus 8 inches. And just so you're clear, the other solution that I would also accept would be to say one is 7 times x plus 8 and the other one is x minus 3. Okay, so you could say this is the length and this is the width. Doesn't really matter which one you put the 7 with. Let's try another very similar one. So again, we're given an area, this time in square meters. I have a leading coefficient of 3, so I'm going to see if I can begin by factoring that out to find my area, or my length and width. That gives me x squared minus 6x plus 8. And then I'm going to try to factor this trinomial into two binomials. Again, off on the side, do your tic-tac-toe. Pause and press play when you're ready to check your answer. Here's my board. One factor is x minus 4 and the other is x minus 2. So the length could be 3 times x minus 4 and the width would be x minus 2, or you could put the 3 with the other one, like 3 times x minus 2. Okay, so it doesn't really matter to me again which form, but again, I'm missing units. This would be meters this time because the area was in square meters. In example 3, a little bit more of an application question. The total area of a painted canvas and its uniform width frame. Uniform width would mean that the frame has the same dimensions all the way around. So if it were 2 inches wide, it's going to be 2 inches wide all around. So that area is x squared plus 17x plus 66 square inches. If the dimensions of the canvas are shown below, what is the width of the frame? And so I know my total area, but what I'm not sure about is what's the width of the frame? So what's this distance and this distance? And I know it's the same all the way around, but I'm going to have to figure out what that is. Right? So I'm going to begin by at least factoring this expression to find overall dimensions of this entire side and this entire side here. Okay, so I'll call this the length and this one here the width. So off on the side, go ahead, do your tic-tac-toe, hit play when you're ready to check your answer. I get x plus 11 and x plus 6. So to get the final part of this, I'm going to refer to my picture. And I'm like, well, which side would have to be x plus 11? Well, to me, that's this length here. It's the bigger one. So this side is x plus 11. And the width here is going to be x plus 6. So how do I find the missing width of this border that would be the same? Well, if from this whole side is x plus 11 and here to here is x plus 5, what's the difference between x plus 11 and x plus 5? Hopefully you notice that there is a difference of 6 units not accounted for. So if I'm missing 6 units to make it to 11, where is it picking up 6? It's not 6 from here to here and 6 over here. Since it's the same distance all around, I would say that it's half that. From here, this width would be 3 on either side, and I'm going to make sure it makes sense with the width. So the original width from this point to this point was x units. I now know that the entire width is x plus 6 of the outer. So again, 6 units off, that means it picks up 3 and 3. So the width of the frame is 3 inches. The total area of a rectangular deck is, that's a typo right there, 4x squared plus 120x plus 800 square feet. You know the length of the deck is 4x plus 80 feet, so I'm going to fill that in. What is the width? So I don't know the other side, but I know my total area. So I think, well, I'm looking for two things that multiply together to give me this, so I'm going to begin to factor to figure this out. So again, I start by factoring out my GCF, which would be 4. Gives me x squared plus 30x plus 200. And now I'm going to try to factor using tic-tac-toe. That's my preferred method. If you know a different factoring method, feel free to use it. Okay, so factors of x squared, factors of 200, and I need them then to add to positive 30. So there's a lot of things I can try here, like 1 and 200, no way, 2 and 100, and there's a lot more, but one that just kind of jumps out at me is 10 times 20, right? That's 200. I'm looking for one that's going to add to 30, so I think it's going to have to be that. Sure enough, that works. So one of them is x plus 10, the other is x plus 20. Now, if you don't have good number sense with your multiplication tables like I do, spotting the 10 and 20 could take you a lot longer. You just list all your factors and go through them all as we have in previous ones. Okay, so what is this side? This side's 4x plus 80. Well, that doesn't quite match any of this, so what did we do wrong? Well, nothing. If you look at this side, the length, that could also be, if I factor out the GCF, 4 times the quantity of x plus 20, so that's this portion. So that means that my remaining part has to be the width, and this part is the length. So therefore, to answer the question, the width is x plus 10, look back at your units, feet. This last problem is an example taken from the Keystone released items. This Keystone exam is made up of multiple choice and what's called constructed response. 40% of your exam score comes from the constructed response portion, so let's get this one down pat. Ken creates a painting on a rectangular canvas with a width that is 4 inches longer than the height, as shown in the diagram below. Height and our length. Okay, write a polynomial expression in simplified form that represents the area. All right, we got this. Area we know is length times width. So we're going to just show our work. I'm going to write h times h, the quantity of h plus 4. And I think, how do I simplify this? Well, simplify means no like terms and no parentheses remaining. So that gives me h squared plus 4h square inches for my area. King adds a 3-inch wide frame around all sides of his canvas. Write a polynomial expression in simplified form that represents the total area of the canvas and the frame. So, this doesn't look very equal, my sloppy writing, but that means he picks up 3 here, 3 here, 3 here, and 3 here. So my new dimensions will be, well, it was just 3 or h inches between this portion, but if we're picking up 3 and 3, now it's going to be h plus, not 3, but 6, okay, because 3 inches on either side. And then this side here was h plus 4, but now it's picking up 3 inches on this side and 3 inches on this side, so it's going to be h plus 6 total more would be h plus 10 for my new, because it was plus 4. So now we're going to find the new total area. So length times width again. And now I'm going to multiply 2 binomials together. So I'm going to double distribute, gives me h squared plus 10h. Distribute the 6, gives me plus 6h plus 60. I'm going to combine my like terms. I see a positive 10h and a positive 6h, which gives me h squared plus 16h plus 60, and that's equal to my area. And again, since this is area, I'm going to write inches squared. Lastly, it says Kang is unhappy with his 3-inch wide frame. So he decides to put a frame with a different width around his canvas. The total area of the canvas and the new frame is given by the polynomial h squared plus 8h plus 12, where h represents the height of the canvas. Determine the new width of the frame, show all of your work, and explain why you did each step. Okay, so I'm sketching 2 rectangles here. It's probably not going to really be drawn to scale, but since I don't have it on this portion, we knew that this one here was h and this is h plus 4 is what's given. So he puts new dimensions. So we've got to find how wide is this frame, and it's equal all the way around. We know our area is h squared plus 8h plus 12. So let's find what the dimensions would be if this is the area. So I recognize I need to factor, pause, and do that. Hopefully you got h plus 2 and h plus 6. So what do I know? Well, which side on the outer part would have to be the h plus 6 would be the bigger side. So this side would be h plus 6. And then this side here would be h plus 2. Well, let's compare. It was previously h plus 4, grows to h plus 6, so how many inches did it pick up? It picked up 2 inches. Some kids will write 2 inches as their answer, but not you. It picks up 2 inches in total, so that means like from here to here is the h plus 4. It picks up 1 inch here and 1 inch here for this distance. Similarly, for this side, from here to here is h, grows to h plus 2, so it's picking up 1 inch on either side. So there is a 1 inch border all the way around. Lastly, it says, and explain why you did each step. So I'm just going to write and kind of explain what I did. So first, I factored the polynomial To find the dimensions of the frame canvas. This to find, or like to show, to find, to get, because they help me explain what I'm doing. Then I'm saying, then I knew that the length changed from h plus 4 to h plus 6. The width changed from h to h plus 2. This means that the frame is 1 inch wide.